The USS AFT is tasked with conducting a long-term operation off the coast of New Jersey. Its goals include sustaining a persistent presence in the region, simulating unexplained aerial phenomena, and gathering extensive environmental and response data. This extended mission will test the full operational capabilities of the mothership, including autonomous drone, fabrication, dynamic fleet reconfiguration, and vessel sustainability over an extended deployment. Primary objective: sustain continuous drone operations to simulate UAP sightings in key coastal areas for up to 3 months. Secondary objective: collect environmental, electromagnetic, and observational data. Monitor civilian and government responses to ongoing activity. Tertiary objective: evaluate the long-term operational autonomy of the mothership, including energy efficiency, fleet maintenance, and adaptability. Deployment zone primary location positioned at 39.5000 degrees north, 73.5000 degrees west, approximately 20 miles offshore. Secondary locations shift position every 2 to 3 weeks to simulate broader regional activity while maintaining stealth. Fleet composition: 10 reconnaissance drones equipped with sensors for atmospheric and thermal imaging. 6 PSYOPs drones designed for dynamic LED displays and erratic flight patterns. 4 EW drones equipped for RF jamming and signal spoofing. Operational cycle drone sorties conducted every 8 hours with staggered deployments to maintain continuous coverage. Fleet adjustments: AI dynamically fabricates, repairs, or repurposes drones to adapt to mission demands. Energy management primary power source: ocean thermal energy conversion or OTEC for base energy needs with a 1.5 megawatt output. Supplementary sources: deploy solar panels during surface intervals, use hydrodynamic turbines while submerged in strong currents. Backup systems: lithium iron phosphate battery arrays provide energy reserves for up to 72 hours of operations during low generation periods. AI optimization: AI dynamically prioritizes power distribution based on operational demand, such as drone recovery versus fabrication. Material recycling and drone fabrication: material conservation. Recycle recovered drone parts and unused materials. AI ensures efficient use of raw materials to minimize depletion. Fabrication workflow: produce up to 20 drones daily during peak operational periods. Transition to lower fabrication rates as the mission progresses to preserve resources. Environmental adaptability: stealth operation. Submerge at depths between 50 to 100 meters to avoid detection. AI monitors ocean currents and salinity for optimal positioning. Weather response: surface only during calm weather for drone launches and maintenance. Adjust operational altitude of drones during storms to reduce risk. Phase 1. Pre-mission setup, AI initialization. Load mission parameters, including navigation waypoints and safe zones. Pre-program drone flight behaviors for PSYOPs and reconnaissance. Fabrication: ensure all 20 drones are operational. Stockpile raw materials for ongoing drone production. Phase 2. Continuous drone operations, deployment cycles, launch drones in staggered waves every 8 hours. Wave 1, 3 reconnaissance drones, 2 PSYOPs drones. Wave 2, 2 EW drones, 2 PSYOPs drones. Wave 3, remaining drones as needed for specific roles. Mission execution: reconnaissance drones, collect environmental data and coastal imagery. PSYOPs drones, execute dynamic light displays and erratic maneuvers to simulate UAP sightings. EW drones monitor and disrupt RF signals, gathering intelligence on communications. AI monitoring, analyze civilian and governmental responses in real time. Adjust drone patterns to prolong engagement or evade detection. Phase 3. Drone recovery and repurposing recovery. Drones autonomously return to the vessel when battery levels drop to 20%. AI manages landing sequences to minimize delays. Maintenance: inspect and repair drones automatically. AI determines whether to redeploy, recycle, or reconfigure each drone. Phase 4. Fleet reconfiguration, dynamic adjustments. Fabricate new drones to replace lost units or meet evolving mission demands. Repurpose existing drones for new roles, such as PSYOPs to reconnaissance. Operational metrics: drone sorties. Maintain at least 15 active drones at all times. Ensure continuous operational coverage of the region. Energy utilization: track power generation and consumption rates to validate sustainability. Data collection, environmental data record weather patterns, electromagnetic activity and atmospheric conditions. Response data, monitor civilian reports, social media activity and FAA advisories. Long-term vessel health, structural integrity. AI conducts regular hull inspections using onboard ROVs. Energy systems, evaluate OTEC, solar and turbine performance over time. Stealth and evasion detection. Risk AI monitors radar and sonar activity. Submerge deeper or relocate if detection is likely. Decoys, deploy dummy drones to distract and mislead adversaries. Power conservation, low-power scenarios. Pause fabrication and non-critical systems. Prioritize essential operations like drone recovery and AI. Emergency response, hull breach. Compartmentalize the affected area and surface for ROV repairs. Critical failure. Execute Red Sigma protocols to neutralize sensitive systems.